All right, well, almost done with this. Let me get a share screen going. So the last kind of collision function in the built-in functions is on controller collider hit. This is called when a character controller hits a collider while performing a move. And I'm going to show you how we can use this to push objects around when they collide with a character. It's also something that you could use to keep track of bullets hitting your character or your character hitting some target. Um, uh, it keeps track of uh, hits to our character controller, which you remember is a capsule around our character. So the controller collider hit, the object that's returned by uh, the hit here, has a number of properties, one of which is the collider that hit the controller, or the collider that was hit by the controller, or the controller that was hit by the collider. So uh, if, uh, if we hit another character, it can also get generically the game object that was hit by the controller. It also has information about the direction that the character controller was moving when the collision occurred, how far the character had traveled until it hit the collider, the normal of the surface we collided with, so similar to the normal that we used in that last example to make splats, as well as the point in world space that we hit something. So that would be where we put the splat. And we can also access the rigid body or the transform that was hit by the controller. So the example I want to show you here is a pusher. And in order to motivate you to see why we would need a pusher, here's a scene with the standard asset first person character, who's a character controller thing. And I've got a bunch of little cubes here that have rigid bodies, and with some fiddling uh, uh, using something analogous to the blob shadow projector that we used back when we were talking about uh, configurable joints. I've got this little text that appears above my objects, and there's a little script that tells whether they're awake or sleeping. Now, if I drive into one of these things, it does wake it up. It does wake it up, but I'm not really able to move the thing. These red ones, because they're bouncy, are a little easier to move. I think because they're bouncier, I can actually move them. Um, but the white ones that are not very bouncy are pretty tough to move. Actually, the old character controller from a while ago didn't even actually have this ability. So in this script, I have a push power. This is how much I'm going to push on objects that I hit. So in on controller collider hit, it returns the hit. The body that I hit is the collider's attached rigid body. So this is the rigid body of the object that I hit. If that is null, that is, there's no rigid body attached, or if that body that I hit is set to be kinematic, I bail, because I'm not going to push around things that A, don't have rigid bodies, or B, are rigid bodies that are set to be as kinematic. I also don't want to push objects that are below us. So I'm going to bail if the hit move direction in the Y direction is too much down. I don't want to push things down into the ground. I want to push things horizontally across the ground. So I'll also bail in that case. So now I'm going to form a vector push direction that is a new vector 3 that takes the hit move direction X and the hit move direction Z and 0 in the Y. So I'm only pushing horizontally And I'm going to assign that to my rigid body's velocity scaled by the push power. This is a vector scaled by the float push power. And so now here's my pusher. And I've actually, I think, put a Boolean in it now so I can turn it on or off. So the pusher's here, I'll do the pusher off first. So this is just like the scene that I just showed you. The objects are asleep and I can't really push them even though it wakes them up. But if I turn that switch to on so that now the pusher functions, now I'm going to be able to push these things all over the place with no problem. I can now push them around like I'm running a bulldozer. So that's very cool. Now, the last thing I want to do here is talk about some of the mouse functions, the on mouse down, on mouse up, on mouse over, on mouse enter, on mouse exit, and on mouse drag. On mouse down is when a mouse button is pushed, and you can actually select which mouse button you care about by putting 0, 1, or 2 in here. That'll select among your 3-button mouses. Up is when the mouse button is released. Over is when the mouse is over the object. Enter is when the mouse enters an object. And exit is when the mouse exits an object. And drag is when you're clicking and holding it. So a simple little script to make an object turn red when the mouse is over it and revert when it exits. Again, in the start function, I'm going to catch a copy of the original color, the original material's color. And in on mouse enter, I will change the color to red. And in on mouse exit, I'll change it back to the original color. I think I also have some that fade to red when the mouse is over it and revert when it exits. So I have now a fade rate. This is how fast I want the color to fade. And in mouse over, as opposed to mouse enter, mouse over, it's going to catch a copy of the color, gradually fade out the red component of it, and replace that replace the material color with that faded color. And of course, when I exit, I'll set it back to the original. So I think now here in test mouse, don't save. I have some A spheres, which I can of course do this with. But if I enter a red one, it turns it red. If I enter a fade one, it fades the red out to cyan and turns it back to white again. Fades it, turns it to red. And I'm not sure but what this might have. It doesn't. Okay. So anyway, those are the mouse functions. A small gotcha, you might be tempted to directly try and fade out the red color of the red color material, material color red channel, and you'll get the following kind of error. Cannot modify a value type return value of Unity engine material color. Consider storing the value in a temp. That's what I did here. Temp is the material color. I fade the red channel of the temp color, and then I assign it back to the material color. And this is true of many vector-3 types, things like transform position or Euler angles, or many of these have this limitation. So I'm going to stop there. I'm going to end the sharing, and I'll stop the recording. And this completes our venture through the scripting API of Unity. See you in class. Bye.